Hi everyone, I just wanted to go over our volumes of revolutions, the disk and washer method. I wanted to go over number 2 from this worksheet, but first let's go over some basic information that we need to know about volumes of revolution. Remember, if you have a disk, that means that you only are dealing with one function, that the area that you're revolving around the line of rotation, there's no space in between. However, if you have a washer, when there is a space between your area and your line of rotation, and then there will be two different equations that you're working with. So if you're revolving about a horizontal line, if it's the x-axis, you do not need to adjust your function. But if it's not the x-axis, you do need to adjust your function. Remember, horizontal lines is all about x. Think top minus bottom. In other words, if the line of rotation is above your area, then you need to do the line of rotation minus the function. If your line of rotation is below your area, then it's the function minus your line of rotation. Again, it's all about x, so y equals f of x. Your limits of integration should be all about x. If you are revolving about a vertical line, then it's all about y, or dy. If it's not the y-axis, then you need to adjust your function. And here you're thinking right minus left. In other words, if your line of rotation is to the right of the area that you're rotating, then it's your line of rotation minus your function. If the line of rotation is to the left of your area, then it's the function minus the line of rotation. It's all about y, so x equals f of y. Your limits of integration are all in terms of y, f of y dy. Okay, so let's look at number 2. I already started to sketch this. And so we have y equals 1 plus radical x. We have y equals 1, and we have x equals 4. So we're looking for the area contained by these three graphs. So I can see that that's this area right in here by these three functions. And so for part A, we are revolving this area about the x-axis. So first I need to determine, is this a disk or a washer? Well, if I'm revolving this about the x-axis, I see there's some space here. So this is definitely a washer. We're revolving it about a horizontal line, the x-axis, so it's all about x. Since it's the x-axis, I do not need to adjust my functions. Since it's a horizontal line, I'm looking at the functions from top to bottom. So I'm looking at my function y equals 1 plus radical x, since this is on top. And I'm looking at my function y equals 1, top to bottom. I'm not worried about x equals 4 because I'm rotating about a horizontal line. So top and bottom is what I'm looking at. All right, so I don't have to adjust them since it's the x-axis. It's all about x, so my x value here is 0, right? This point is 0, 1, so my x value is 0. And this point over here is 4. And I have my pi. So now to set this up, it's outer minus inner. Outer is the graph further away from my line of rotation. So since I'm rotating about the line y equals 0, notice y equals 1 is closer. So 1 plus radical x is further away. So it's 1 plus radical x squared minus 1 squared dx. And you can just plug that into your calculator to get your answer. Now let's look at B. B, we are now taking the same area and we're revolving about the y-axis. So the y-axis is a vertical line, so I know this is all about y. And if I look at my area, if I'm going to revolve this around y, notice there's some space here. So this is a washer. It's a washer. It's a vertical line, so it's all about left to right. So my two functions now here are from the left. This is my y plus y equals 1 plus radical x. And to the right, I have x equals 4. So it's right to left, right to left. I'm not worried about y equals 1 right now. But this is all about y, so this is good. This is x equals 4, but I need to get this as x equals. So if I subtract 1, I get y minus 1. This is radical x, so I will square this. And so here's my new function in terms of f of y. So I have my x equals for both, and now I can set up my integral. So now I have pi. This is all about y, so this point now is 0, 1, so 1 is my y value. And when x is 4, this is 3. All about y. All about y, so it's outer minus inner. So what's further away from the y-axis? Well, this guy's closer, right, the blue. This is further away, so 4 is further away. So I have 4 squared minus y minus 1 squared, and this guy has to be squared. So outer minus inner zy. Be careful here that you see the two squares, because this is your function and your function has to be squared. So you can plug that in to get your answer. Now let's look at part C. So C, we're now revolving about the line y equals 3. So let's draw that in. Y equals 3. Sorry, my line's not so straight. Y equals 3. I know they intersect here because I know this point here, when x is 4, well, square root of 4 is 2. 2 plus 1 is 3, so they definitely intersect here. And so now I'm revolving about a horizontal line, so it's all about x. However, it's not my x-axis, so I do need to make some adjustments. But, okay, wait. First, let's notice I'm revolving this area over this line. And again, there's some space here, so I know this is a washer. It's a horizontal line, so I'm looking at this area from top to bottom. So top I have y equals 1 plus radical x, and on the bottom I have y equals 1. Again, since this is not the x-axis, I need to make an adjustment, and so this adjustment is, think top minus bottom. My line of rotation is above the area, so I'm going to take my line of rotation minus my function, 1 plus radical x. And so my new function becomes 3 minus 1 is 2, negative and a positive is negative radical x. Here is my new function. And over here, again, top minus bottom, so I have my line of rotation. So 3 minus 1 equals 2. So here are my two functions. So now let's set up the integral. So I put my pi here. It's horizontal, so it's all about x. So again, we're going from 0 to 4. So 0 to 4, outer minus inner. So outer, again, is the guy further away from my line of rotation. This one's closer, this one's further. So this function, which is represented by 2, is further away. That's my outer, minus 2 minus radical x squared dx. Outer minus inner, we made our adjustments. It's all about x. So you can plug that in to get your answer. Now let's look at part D. Part D, we're now going to revolve this area about the line x equals 6. So let's draw that in. x equals 6. X equals 6. So now we're taking this area and we're revolving it around this vertical line, x equals 6. Okay, so first thing I notice, there's space between my area and this line, so I know this is a washer. It's a vertical line, so the two equations are from right to left. So I'm worried about this blue line, which again is my y equals 1 plus radical x, and this line, which is x equals 4. This is not the y-axis, so I need to make an adjustment, but actually before I make my adjustment, since this is a vertical line, it's all about y, I need to rewrite this again. We did this before. All right, so I subtract 1. I had 1, y minus 1 squared equals x, right, because it's all about y. Again, it's not the y-axis, so I need to make adjustments. So let's look at this first guy. Let me just rewrite this here. So since my line of rotation is to the right of this area, it's going to be right minus left. So I'm going to have 6 minus this function, y minus 1 squared. This is my new function. And here is 4, so I'm going to have this guy become 6 minus 4, which equals 2. So these are my two functions now. So I have my two functions. I can start to set up my integral. So I'll draw my integral. I know there's pi, because these are washers. It's all about y. So here is 1, right, because this is 0, 1, so I'm taking the y. And here is 3. Outer minus inner. So here's my line of rotation. What's further away? The blue guy's further away. This is my outer, represented by this function. So I have 6 minus y minus 1 squared. And this whole thing is being squared. Since you're using your calculator, you can just leave it like this. But be careful with your parentheses when you're plugging this in. Minus my inner function, which has been adjusted to 2 squared. It's all about y. These are y's. This is in terms of y. Outer minus inner dy. And so you can get your answer. I hope this video helped.